Hello, my name is Abel Duprat, and I'm an undergraduate research assistant at Northern Arizona University. Today, we're going to review creating SBML files and using those files to run simulations of SBML models with PyBioNetFit. PyBioNetFit is a software package that supports parameterization of biological models that is being developed at Northern Arizona University and Los Alamos National Laboratory. Documentation about the software is provided below. In our previous video, we went over how to configure a fitting job to run on PyBioNetFit and the configuration keys necessary to do that. That job utilized a BNGL file, and so today we're going to go over how to run a job on PyBioNetFit that is utilizing an SBML file. There are different ways to create an SBML file, but I am going to show you how I created one using the software Copasi. This is not a Copasi tutorial, but rather to show those of you that use Copasi how to set up a fitting job for PyBioNetFit. There is a link below for the installation software as well as for the documentation for Copasi. I am going to open my Start menu. And then I'm going to open my Copasi software. Here we go. And so here is the layout of it when you first open it up. There are a few options on or different branches on the left side here. And so right now we are adjusting our model. And in model, you can set the name of your model, the different time units and different units that will be used, as well as the initial time. And so I will just name this, do EPS, time unit seconds. I'll change my volume unit to milliliters. We'll do millimoles. And I will keep my initial time as 0. Once you have all of these set on the first model page here, you will click Commit to save it. So next, I'm going to click on this arrow to open the model subsections here. And we have biochemical and mathematical. I'm going to expand biochemical, and I'm going to click on reactions. So here you can type in the reactions for your fitting job. And so we'll do reaction 1. We will do X equals yes. And so I'm making this a reversible reaction by doing the equal sign here. Second reaction as ES, and an irreversible reaction creates E plus P. So now we have our two reactions here. And you may have noticed that as I was working on this, the number of species that we had changed. It is pulling the species from the reactions that I created here. So now I have a species of E, ES, P, and S. And you can click on if you click on the arrow next to reactions, you can expand it so you can see each individual reaction. And if you click on each individual reaction, you can make sure that it's reversible versus irreversible. You can alter the values of your constants, and you can make any changes individually to each reaction there. So now I'm going to go back up to species. And like I said, we have all of our species listed here, and I'm going to change their initial concentrations. So now I have my E and S having an initial concentration of 10 and 4, while my ES and my P have an initial concentration of 0. And so once we have all of these set, we can now export our SBML file into the folder containing our job. And I will do that by going to File in the top left corner and Export SBML. And so this is actually my SBML job, but if it didn't direct you directly to it like it did for me, you can go to the folder containing it on the left side here. And so the extension for the SBML file is XML. So when renaming it, you do have to make sure that that extension is still intact. But I am just going to name this EPS like I did my model. So now that that is saved, I will also go and save this. This would also generate a new file, and it saves it in the CPS file format for Copasi. And then if we want to save that, I will also call this one EPS, and I'll just save it in the folder for my job as well. So now we can close out Copasi. So now I'm going to open the folder that has the files for my job in them. So what you can see in here, I have the SBML file that I created using Copasi. And the other files for this specific job are my data files and then my configuration file. There are no specific changes that has to be made to the data file. That still contains your quantitative data, and that one will run as it did whether we're using a BNGL file or an SBML file. The configuration file is a little different when running an SBML file than when we were running a BNGL file. And so I will open this up to show the changes that we will have to make. And so this configuration file, it still has the similar blocks to when we're running a job with the BNGL file. And so you can see we still have our model, the fit type and objective functions, as well as our parameters. The difference is the addition of the simulation action block here. In the BNGL file, our action block was included with the BNGL file. But when running an SBML file, it is included in our configuration file. And so you can see here, there is a structure to how this one is written out, and there are some defaults that would be set if you omitted to enter some information. But you can see I specify my time, the suffix, which would be my data file, the number of steps, which model I am utilizing, as well as which method we are using. And so I am going to open the documentation for PyBioNetFit so that we can go over what some of these are here. And in the PyBioNetFit documentation, I am going to go to configuration keys. And within configuration keys, I am going to select simulation actions. So this defines what each one of those sections were within the simulation action. You will notice that the one that I did not include is subdivisions. That one is only used with the SBML integrator Euler, which we are not using in this example here. But as you can see, the time is required, the suffix is required, and if you do not specify your suffix, it defaults to this time course. The steps would default to 1 if you do not specify. You do have to add your model, or else it will default to all of the models within that folder, and the method that you would like to use. I am using ODE, but it shows here that the default is also ODE, but these would be the configuration keys for the other methods that you can add there. So once we have all of this specified, we can now run our job on PyBioNetFit. So I will close out of here, and I will close out of here. So as I said, there are no additional changes that would have to be made to the EXP file, but let's take a look at it. So we went over the layout of the data file in a previous video, but on top here at the header, we have time, and then followed by that, we have each of my observables. And then going down, we have the data that I have for each one of those observables, at each specific time going between 0 and 10. And so PyBioNetFit is going to find the data between time 0 and 10 that is a best fit for the parameters that I set in my configuration file. And so, like I said, there are no changes that would have to be made to the EXP file here, but I did want to show you what data I had, and then we'll compare it to what PyBioNetFit finds at the end. So I will close this. Once you have your SBML, EXP, and config files set, we can run the job on PyBioNetFit. First, we will copy the address for the folder that contains the file for my job. And I am going to do that by coming up here where it says the name of my folder. I will right-click on it and I will copy the address. Once I have that copy, I am going to open my Anaconda prompt. And I will go to my Start menu. And I will go to Anaconda and Anaconda prompt. And on the first line here, we want to type CD space, and then we will paste the address for our folder by pressing Control V. Once that is in there, we can press Enter. So now on this second line, we will type the command to run the job. And so we will do that by typing PyBNF space -C space EPS underscore XML dot CONF and press enter. This will just take a few seconds because this was a smaller example, but I will just jump to the end here when it is finished for us. Okay, so now that we have our stop criterion, our job has finished running, our fitting is complete. So I can close out of this by typing exit and hitting enter. And I am going to open Kapasi again in order to view our results. Our results were saved as an XML file within our fitting job. And so I will actually show you that also. So if I go back into my job, I had specified for my results to be saved in the output folder, in this SBML XML folder, and under results. And then the results SBML file shows up here. And so now I'm going to open this file in Kapasi. And I will do that in Kapasi by going to File, and we are going to import that SBML file that I just showed you. So I'm going to select Import. And this actually led me straight back into that file, but if it does not for you, you would just have to direct it to it. But I will select my file. And in order to view it, I'm going to go into Tasks and Expand, and I will click Time Course. So in Time Course, we can change, or we can alter our duration, our interval, and our interval size, as well as plot our data and view the results from our data. And duration would represent our x-axis, and that would be the time that has passed in the units that we have selected. In this case, that was seconds. So I'm going to actually make this 10. And then interval and interval size, those are similar to our steps and step size. So I'm going to make my interval 10 and interval size to 1. Perfect. You could also select automatic if you just wanted if you wanted the system to determine these steps for you. And so now that we have our duration, interval, and interval size set, in order to plot our data, we do need to go to Output Assistant in the bottom right corner here. And in Output Assistant, we will select Concentrations, Volumes, and Global Quantity. And we will select Create. Once that has been selected, now on the left side, we can select Run. And so here you can see the data that has been plotted for us. and our species have been color-coded. And so you will have a graph of the data from PyBioNetFit, and you can save this if you would like to view it for later. And to see the actual data that was used to create this, I will close this for now, and I will go, if I come back to time course on the left side, and I select it, beneath it there is results. So when I click on results, I can see the time on one column, and then all of the data points for the species within the specified time. And so that's what was used to plot the graph, which I can bring up again here. So that was used to bring this up here. So I will close this out here, and I will exit Kapasi. So to summarize, today we created an SBML file using Kapasi. We ran a fitting job with our created SBML file by using PyBioNetFit, and we're able to view the results generated by PyBioNetFit by importing the results into Kapasi. Once again, my name is Abel Duprat, and thank you for watching. So long.